In this video, we're going to be tackling the LeetCode question, search a 2D matrix. And this question is important because it forces us to ask ourselves a philosophical question. And that is, what exactly truly is length minus 1? Why is length minus 1 everywhere? And why don't we just have something like this, a property that states end of array? If we want to grab the ending element of an array, why do we use length minus 1? Length minus 1 is actually important because it represents an explicit conversion from the number of elements to an index. Let me explain. If we want to find the number of elements in an array, what we do is we just take the dot length, and that's going to give us 3. There's 3 elements in this array. But that's just the number of elements. That doesn't really do anything else. If we want to grab something, if we want to index something, want to get something out of this array, and more specifically, we want to grab something from the back, what we do is we convert the length to an index. We say length minus 1. And it goes from just a regular run-of-the-mill number of elements to something that we can use to actually grab elements out of the array. But this is easy. How exactly are we going to do this when we have, let's say, a matrix, a nested array that looks something like this? Well, what we're going to do is we're going to take the length of the individual arrays within the nested array, and we're also going to find the number of elements within the entire array itself, the number of arrays that exist within the arrays. That's kind of confusing, so let me explain it in a little bit more depth. So in order to obtain the very last element, let's say that I want to grab 60 out of this nested array. Easy when it's just a single array, but how do we do this when it's nested? Well, look at it like this. This nested array is very similar to an Excel spreadsheet. Matrices are almost no different from Excel spreadsheets, and if it helps you, maybe lay the matrix out in rows and columns, just like this. We have horizontal rows, and then we have vertical columns. And we can actually access the number of rows and columns. And we can do that by using length, like we did before. If I want to find the number of rows, which is essentially the number of arrays that are contained within this whole entire array, I can take array.length. And that is going to be 3 in this case. That is the number of rows. But if I want to obtain the number of columns, essentially the number of elements within each array, what I do is I take the length of the very first array, and that is going to give me 4. But remember what I taught you. This is just the length. This is just the number of elements. This isn't the actual index. If I want the actual index, what I'm going to have to do is I'm going to take the number and I'm going to minus it by 1, which in this case is going to equal 11. But here's the thing. 11 is indeed the index for the last element, but it's the index of the last element for a 1D array. If we just had a 1D array, we could use 11, but we're going to have to convert this into a 2D array indexer. How exactly is that going to work? Well, we're going to need to convert this index 11 into something that looks like this. We have the array, and in the first bracket we have 2, and the second bracket we have 3. And this is the row, and this is the column. So row 0, 1, 2, column 3, 0, 1, 2, 3. This is what we want, but how exactly do we do that conversion? So if we want to find the accessors for the matrix, for the rows and the columns, these two numbers right here, and we want to derive these two numbers from the index of the last element, what we use is we use this math. And this math is very simple because we've already done most of the heavy lifting. N is going to be the number that we want. which is 11. We want the last element. So we divide it by the number of columns, and the number of columns is equal to 4. Hence the 2 in the first bracket. Then what we do, if we want to find the column index, the column accessor, we do the exact same thing. We mod, but we mod by the columns. And when we mod by the columns, we get the remainder 3. And essentially what we've just done is we've converted this 1D array index into a 2D array accessor so that we can actually get the elements out. So here's the thing. Everything that we've done thus far has been a setup for the bigger picture. And that bigger picture is that we need to perform a binary search on this matrix. We know that because at the very bottom of the LeetCode description, we see the sentence, must write a solution in log m times n time complexity. And when you're working with search and you see that, you have to use binary search. Here's the thing though. A regular binary search really isn't that complicated. And with what we've just learned about converting a 1D array index into a 2D array accessor, we can quickly convert a regular binary search into a binary search that can search this matrix. All binary searches boil down to the same fundamental concepts. The first fundamental concept is that it's a search. So what we're going to do is we're going to search for 5 in this case, but this could be any number that you want. Second thing is that all of the numbers must be sorted. No ifs, ands, or buts. All of these numbers must be sorted because what we're going to do is we're going to find the middle. Then we're going to determine if the number is on the left side or the right side. And because it's not on the right side, we can go ahead and rule out the right and continue splitting the left side down the middle. Here's how this is going to work. Just like with any other binary search, we're going to have a pointer at the very left, and we're going to have a pointer at the very right. And what we're going to do is we're going to find the index for this last element. And we're going to do so using the lengths of the individual arrays. And we already did this before. The number is 11. So what we're going to do is we're going to divide it by 2. That's going to give us 5. This is the middle in 1D format. But in order to access this number, we're going to have to convert it into 2D. We're going to use the same exact math that we did before. So in order to find the row, what we're going to do is we're going to take that 5 and we're going to divide it by 4, the number of columns. And in order to find the column, what we're going to do is we're going to mod it by 4. This is going to give us 1 and 1, so we can finally access this 11. And because we now know, because the numbers are sorted, that the number that we're searching for is on the left side, what we can do is we can get rid of this pointer, and we can only search on this side. So currently, our right pointer is going to be the max. And what we're going to do is we're going to divide that max again by 2 because we're trying to find the middle within these 2 pointers. And when we do that, it equals 2. But this is the index for a 1D array. We need to do the conversion once more. So we do the row, 2 divided by 4, that's going to equal 0. And finally, we're going to do 2 mod 4, which is going to equal 2. So in this case, our middle number is going to equal 5. That is the number that we are searching for. So we have indeed found the number within the binary search. And that's how the algorithm works. Let's hop over into IntelliJ and let's code it. So we are inside of IntelliJ. And first thing that I'm going to do is create a brand new Java class. I'm going to call this solution. This solution class is going to house our method. And the method is, of course, going to be public. We're going to return a Boolean. Thank God, because this would be way more difficult if we had to return an actual number. And we're going to name this method search matrix. It's going to take in, you guessed it, a matrix, and it's also going to take in a target number. So, per usual, before we do anything else, let's go ahead, do a couple edge case checks. And if the matrix is not there, if the length is equal to 0, or if the matrix that's within the array is equal to 0, we're going to go ahead and return false. Let's go ahead, create our state. This is where we're going to go ahead and pull out all of the lengths. So I'm going to go ahead, do my rows. This will be matrix.length. do the columns, so the individual array within the actual nested array itself. We're going to go ahead and grab the first one because all of the arrays are the same length. Then what we're going to do is we're going to create our pointers. So we're going to create our left pointer. We're going to create our right pointer. And this is going to have some pretty cool logic. We're going to times the rows by the calls, and we're going to minus by 1 so that we get that juicy index. As with all binary searches, what we're going to do is we're going to create a while loop that's going to check if less than or equal to the right pointer, or if left is less than or equal to the right pointer. We're going to go ahead, get our mid. You could do it like this if you want to, but per LeetCode best practices, what we're going to do is we're going to say left plus right minus left divided by 2. And that's going to make sure that we handle really big numbers. So before we do anything else, there's many ways that we could do this. I'm going to go ahead and do the row conversion, the matrix conversion. And remember, our math is mid. So we're going to take our mid and we're going to divide it by our calls. And then we're going to find our call, our individual column, by modding the mid, just like that. Then finally, let's go ahead and abstract out the mid value so that we don't have to keep typing all of this out. And we obtain the mid value by taking the row and the call that we just calculated and plugging them into the matrix C brackets. So before we do anything else, before we do any moving of the actual pointers or returning anything, we want to succeed first. Remember, fail or succeed first. And we succeed by obtaining the middle value. And if the middle value is equal to the target, that is the number that we're searching for, so we don't want to continue any further. But if the mid value is less than the target, what we're going to do is we're going to turn the left pointer into the mid. We're going to say mid plus 1 because we don't want to include that number. Then lastly, what we want to do is if the mid value is greater than the target, what we're going to do is we're going to move the right. And we can just simply use an else here. We're going to say right is equal to mid minus 1. And last but not least, if these two pointers cross, what we're going to do is we're going to return false. That means we didn't find the number. And that's pretty much it. So let's go ahead. Let's get a full screen mode here. And I'm going to go ahead, bring over LeetCode very quickly. So when I bring over LeetCode, what I'm going to do is paste this code into the code editor. I'm going to move this over. I'm going to go ahead and hit that run button. Thank God it's accepted. Let's hit the submit. Let's make sure that we're log in, I should say. So let's say time complexity, log row columns. Then we're going to see the memory is constant. Hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button. As always, thank you for watching.